and it talks more about maybe your code, your design code, your foundation, the code. For design code, we are using 410. For steel, we are using 5150 rather. For this load, I think I talked about this code when I was doing the preliminary class, 6399. Then in
Yes.
case if you are doing
Of course.
design for outside Nigeria, because Nigeria, we don't have any issue of earthquake, but if you are outside the country or places that can be subjected to earthquake, you pick your code too and select and pick. There are several options. There is Turkish code, there is Euro code, depending on how you want to, the one you want to use. You can always select the one you want to use. It's going to come on. But for the sake of this project we are doing, and because we are assuming our project is in Nigeria, so we don't have any cost to select any
To
earthquake
consider
code.
earthquake
So I
code.
will discard that.
Okay.
Then foundation, we have the allowable stress of soil rather. See, I want to set this as a note. It's very, very important as an engineer, as a structural engineer. If you want to do your design, your client should not influence anything, irrespective. There are some people
Sir?
they will tell you, okay, our site, the soil there is very, very strong. Just help us design, assume. No, you have to get a soil report. As I've said, soil report is not just only to know the soil bearing capacity. It talks about a lot of things about the site. In fact, without you going to the site with the soil report, you can easily predict what is going on and what you are likely going to see if you go to the site. So we are going to assume that our building is on a very rigid soil, and we've done our soil bearing capacity. We have our soil bearing capacity from our soil report, and we are going to assume it's going to be 150. Then we assume that it's on a dense sand or medium to dense sand. Either of the two is good. Then lateral load. We are not going to use this because this influence another thing. So you can just leave it. It's not a big deal. It's a big deal when it comes to where it's supposed to be applied, especially when you have structure that has shear walls. You have to consider this. This has to come into play. Then the lateral drift. The lateral drift talked about the columns, if they are going to be braced or unbraced. Generally, we consider our columns to be braced because it's a residential building. That is one. Then the project we are working on, mind you, we have block wall virtually around it. In both direction of most of our columns, what's it called? They are in between walls, like we've embedded them into walls, so they are braced. Lateral bracing, we have lateral bracing for our columns. So for both directions, we are going to assume they are braced and braced. So we are not going to alter anything here. Are you following me?
Yes, sir.
Okay, then the title, this is where you alter the title, you input the title. Okay, let's say this project is for, what's the name of the coordinator of this bootcamp?
Baby Sola.
Engineer Gbemisola
Yeah, Sola. Baby Sola. Engineer Baby
Gbemisola
Sola.
Residential Development. So it's going. What's your name again, Mr. Habib?
Huh? Yes,
ED,
sir.
ED, checked by, let's say, BE. This will be the name of the person that is going to check and the stamp is going to be on it. Then project number, let's give it bootcamp 001. Oh, this month is 6, then 2022. Project date 06 2022. So all these things, they are very important because by the time you finish your design and you want to export your calculation sheet, all these things will be on it, and it makes our work more distinct, and it gives it more value. Like you have more details to speak on. You understand? These are basic things you have to do before you dive
Yes,
into
sir.
your project modeling. So we okay that this is where we have on setting building set out. Then select story, that will be later. You have not created any story yet. Insert story, this is when we have created and want to add another story to it. We are going to come, we are going to use all this later. The member tables, this talked about, okay, if you have members and you want to have their whole list, this table prepares everything. List of axes that in the modeling, the column, the wall, the beam, etc. Then the support type, this talks about the foundation, more about the foundation. Then the slab additional load, like if you have another load, additional load that you are trying to add to your structure, basically slab. Then we have the wall type library. This one too is for wall. Just as this is for slab. Are you there?
Yes, I'm with you, sir.
Okay. Then we have the concrete member, the concrete column, wall, beam, slab strip. What slab strips is used in design of slab. If you don't strip your slab, the software will not design it. You understand? And strip
Yes, sir.
is very important. You know, there was a time when I don't know if you have watched the old video. There was a time I was asking Mr. Shuaib about a slab that is looking like a cantilever while preparing the GA. I think let me show you this the layout. Yeah, is this. Can you see my screen?
I can't see. I'm seeing your screen, but I didn't see the one you open
I've
now.
op-
Maybe the AutoCAD
okay.
file.
I've launched
The
AutoCAD
network
now.
kind of slow.
Okay, is this area? I know you will see it later. This is the slab I'm talking about. This slab looks like cantilever, and it depends if I'm the designer. I can design out to make it a cantilever. It depends on how I'm stripping it. If I'm stripping it in the YY direction first, that means I'm taking it as a cantilever.
Okay,
Do you
sir.
understand?
Please,
So if I'm stripping it
I can
on
see
the
it now.
that means I'm taking it as a one-way slab. So that's where the slab strip
Hello, sir.
comes in. I can hear you.
Hello, sir. Okay, sir. Can you help me? Can you please re-explain that side? I can see the slab now, and like the AutoCAD has shown up now.
Okay, very good. Okay, maybe I will draw a line.
Hello, sir.
Hello, I can hear you. I'm still there.
Okay.
Okay, this is YY that I'm talking about. So assuming we have modeled this structure now, and I strip it along this YY first,
Okay.
it's going to take this guy as a cantilever. So my bottom reinforcement, that means when we get to site, the first set of reinforcement that they are going to lay on site is going to be like along this axis I have drawn, like this, like this. Just assume they're going to first lay the net. It's the spacing with the right spacing. Have you seen what I've done now?
Yes, sir.
Yes, this is the case when we strip this slab on y axis first. But let's assume it's the other way around. We we have decided, and with this now, let's assume how is this slab going to behave? All the load of this slab will go to this beam at the end because that's the only support that is on that strip. Now, if I cut in the other direction, that's XX. X. XX. So what this means is you are telling the software that okay, the load distribution is not going to be in YY direction, it's going to be in XX direction. So that means this beam and this beam in here, they are going to be the receiver of the load. Do you understand? And when they are laying
Yes,
reinforcement
sir.
on site, they are going to lay this one first. Do you understand?
Yes, sir. I'm listening, sir.
So that is what the strip is talking about. Someone
Okay,
wants to
sir.
join. Nobody join. So that is what this slab strip is doing. Then we have the floor plan section, we have the slab load, we have the slab opening. Let's say you have created a slab and you want to create a hole there. Although there is treatment for hole in slab, you have to provide for your shear reinforcement at the edges at an angle 45 degrees. Then we have the plane definition. We have the slab column edge. So this will, if you want to draw a curve slab or something, then insert slab automatically. Then that's that. Then the version of ProtaStructure I'm using has steel design too, but what we are doing does not involve steel. So this talks about steel. Then this is the analysis. We are going to use this later. This is the column design. We are going to use this later. This steel design, we are not using it since our project is not a steel structure. Then we have settings. Hello, are you with me?
Yes, sir.
Any questions so far?
No, sir.
Okay, very good. Now we have the settings tab. This is where you set a lot of things. Now this one we have done this already. We have already imputed the code that we want to use. So there's no need for us to do anything on this. Then we have general settings. These general settings, and this is where you you alter the number of time or intervals that you want your software to be saving your project. So what I've done now is I inputted five 5 minutes. So in every 5 minutes, this project will save what we are doing automatically. Then we have the company. You can decide to edit this. Then we call it bootcamp project. Let's say bootcamp engineering. So that's the name of the project. And we save it. We go back there again. Member label. This one, just leave it as default. There is nothing so serious here. Then layer. Don't need much about this. Then tool column design. This is another thing. Column design. Later I will come back to all this. We are going to treat all this. Then beam also. We're going to treat it. And then slab design settings. Later we're going to treat them. So that's basically what we have. Everything you are seeing here on the second level of this tab, they are just subsection of all these major ones we have at the top, just for easy access. You understand my point?
Yes, sir.
Okay, now, so we want to start modeling now. We have done some prerequisite settings, like we've defined our soil bearing capacity. We have given the name of the project, the file name, the file dates, the name of the checker, the name of the person doing the design, and others. All these are very, very important. You have to do them so as to have a proper report at the end of your design. So now we proceed. We import, as I've said, what we are going to do is we are going to import the drawing that we have converted. I don't think we have converted it to DXF.
No, we have not.
We haven't. So that's the first thing we are going to do. Can you see my screen?
Yes, sir.
AutoCAD.
Yes, yeah, I'm seeing AutoCAD.
Okay, very good. Now, Control S. I'll save it as Prota import. Now we target DXF. Let's say 27. It's fine. Nothing changes. It's saved. Then we go back to that directory. Import external and we load. Okay, total import. That's the file. Is in mm. Now, what are the things you want to import? We can only import two things, just the axis and the column. So we want to import the axis and likewise import the column. Mind you, what's the name of the grid line of the over grid line?
S grid line.
S grid line. S grid. S grid. S grid. Then our column. Column. Then we okay it. And it's telling us there is a modification somewhere. Maybe there is an axis that has deviation very small. This like 360 is less than 1 degrees, but it has to detect it because it has zero tolerance for deviation. So we ask it to automatically do it for us. So we do a thorough check to see if there is any overlapping anywhere. It does a slab check, column check, slab with beam and wall check, column inside slab panel check, all these checks that we have here. When you're using the software, you can read through them. Because of time, we'll not be able to be touching them one by one. So it does all this check, and if there is any error in any of them, it's going to prompt you. Then it's going to tell you where you have the error, so you can correct and probably import again. So we start. So we have zero error. It's done. Then we cancel it. Now, mind you, after pressing close, you can see that the interface here has changed. What we have here, where my cursor is going around, has changed. So that shows the software has
Yes, sir.
recognized what we have imported. So we close it. Now you can see all our first floor columns have been imported and our grid lines. But there is one thing I don't like about the interface. I always want my grid line to have the same definition, the same grid name as what we have in the layout, especially in the architectural drawing. Because when you are on site, there is always need to juxtapose between the structural drawing and the architectural drawing and other drawings that are involved in the project. So having a uniform grid line is very important. So that's the first thing we are going to do. So after we've done importing our file, our DXL file into the ProtaStructure, then we edit our grid lines to ensure that it's the same as what we have in the architectural drawing, because that's the reference for every other drawings. So what we are going to do now is I always partition my screen. Okay, this is A, this is B, this is C, this is D, this is E. Can you see my screen?
I can see it.
Okay, I've partitioned it into two now.
Yes, sir. I can see the two.
Okay. Okay, these I will click on it. You can right click on it, right click on it, click on it, it's clicked, then now right click. That's the step. You first click on it, then now right click on it. With that, it's going to give you some other options like properties. You want to offset the axis, you want to move the axis, you want to stretch it, and other things that you want to measure, you want to delete, you want to make mirror. There are a lot of options you can do with it. But what we want to do is we want to change the name of the grid line. So and that deals with the property. So we click on properties, we come here, we edit instead of Y5, we input A to update with that. Okay, it's giving us sand. Why is it giving us sand? The sand is telling us that there is already an axis that is bearing A and cannot have two A's in the project. So what you're going to do now is you check. You come to this dialog, the dialog side. You see that which one is A. You click on A. Where is A? Oh, it has already named this as A. So what we are going to do is we rename this. We give it something else. We can give it, let's say, A prime or something, and we update it. So with this now, we don't have A again. So we are going to edit this property. So we can go ahead now. We update. You can see it has done. Are you with me?
I'm with you, sir.
Okay. That's it. Okay, the next axis is this Y9. It's saving. Okay. Okay, we continue. This is B. Give it the I'll update that. Then the next axis, that's C. The next axis, that's D. And the last one is E. Now, we have some axes that come before A. I always like to reference them with the main axis. So I'll take this as, let's say, A prime. Update that. I'll take this as A triple prime. Which other one? Because everything that is on the left side of A, I will target that to A. Anything that is on the left side of B, I tag them to B. That are on the Y axis. Like this one now, I can target B prime. Because it's on the left side of B. Likewise, do we have anything on the left side of C? No. Do we have anything on the left side of D? Yes. We can tag this D prime. We're done with D. Then we have E. This one is on the left side of E. And I'll target E prime. Then this is also on the left side of E. I will tag it E prime prime. Then are we done? No, not yet. Okay, this guy I can tag it also E because we don't have any other. Okay, let's tag it F. You can tag it F prime. Because what comes after E is F. Tag this also F prime. Right. With that, all our vertical axes, we have given them a defined axis name. Are you following me?
I'm following. I'm listening, sir.
Thank you. Okay, then here we have this is 1. Update it. Then we have this is 2. We update that too. This is not 2. Okay. 3 has gone off. Let's grid line 3. Okay. This is actually grid line 3. So this grid line 3. This is grid line 4. What I'm doing are just repetition. 4, 4 prime, 4 prime prime. Then we have which one is 5? Okay, the one that follows 4 is 5, which is this guy here. So this is actually 5. We update it. Then this is 6. This is 7. We update it. Then we have this last grid line to be hit. Then I close it off. So as I've done for the vertical axis, I will do the same to the horizontal axis too. Anything above 1, I take it as 1 prime, 1 prime prime as it goes. So this is above 1, I take it as 1 prime. One prime, good. Is there anything above 2? Nothing. 3, we have 3. Is there anything above 3? None. We have 4. Is there anything above 4? Yes. We have something here. 4 prime. And we can tag this 4 prime prime. Then we have grid line 5. Is there anything above 5? Yes. We can convert it to 5 prime. We change this to 5 prime.
Hello.
Hello, I'm with you.
I can't see your screen anymore.
Okay, give me. I'm coming. Oh my god. I have to plug my laptop. Okay.
Okay.
Okay, can you see my screen now?
I can see your screen.
Okay,
Yes, sir.
very good. I'm done with all the grid lines above 5. So the next grid line I'll be working on is 6. We only have one grid line above 6. So I will tag that grid line 6 prime. Update it. Then we have 7. Is there anything above? Yes. We have this. I can target 7 prime. Then we have 8. Is above 8. Keep it first. Right? So then this. 8 prime from radar. Okay. Do we have any other one? None. So we have moved past 8 now. We want to tag this 9 prime. So with this we can only check. We shouldn't have something Y or X. Okay, we have 1. Then so we have to tag this D prime prime. So if you check around now, we should have something like X1 or Y1 or X10, Y10. Everything should be something related with what we have in our architectural drawing. On y-axis, everything is alphabetical, like we have alphabets. Then on the horizontal axis, we have numerals, like 1, 1 prime, and so on. Do you get that? Hello, are you with me?
Yes, I'm with you.
Okay. Now, the next thing you do is you check your column eccentricity, because there are some times that while drawing your GA here, there might be deviation in the center centroid of your columns, and that will influence design. Because if there is any, let's say even if it is 15 deviation, is the way the software is going to analyze it on your column is going to create, is going to induce moment, and which might create excessive reinforcement, or can even tell you that column is not passing, will not pass. And in actual sense, that column ought to pass. But due to the modeling, probably someone has not done thorough checking. You understand? So these are some of the prerequisite things that are important. They might be minor, but they go in the long way in helping the results of what you have. So what I will do now is I will check my columns. How do I do that? I come here to the to the story tab. I click on the first one, then hold on shift, click on the last one. This highlights all the columns. Then I will right click to see their properties. Now with this property now, you can see that some of them has -2. They have -2. We have some that has 2 eccentricity. Then we have some here that has -2, -2, -2. You might see as -2 mm is something. If you have a 1000 kilonewton load and you multiply it by that, the moment that will be induced on the column might be something significant later. So it's always good to do a double check. So we check on all these columns now. Like let's say column 2, the software is telling us it has eccentricity of E1 on x-axis and pardon, E1, the eccentricity is -2 mm, and E2 is eccentricity of -2 mm. So we'll check our model. Where is column 2? We see if it is real or actually. If it is not real, then we find a way of making it right. Do you understand? Hello, are you with me?
I'm with you, sir.
Okay. Do you understand what I've just explained now?
Yes.
You said you're in which level?
400.
Okay, you must have done column design.
Yes.
Okay. There are different types of columns when it comes to column design. We have axially loaded column.
I'm
We have
loaded.
uniaxially loaded column, and we have biaxially loaded column. Now, if you are assuming your column is axially loaded, but you're having eccentricity here, so that means your column won't be axially loaded again, because the column will not be resisting only axial force. It's going to be resisting both axial force and moment with what we have here. Do you understand?
Yes, sir.
So that is why it's very important to do all these checks. So
Hello, sir.
are you with me?
I'm with you, sir.
Okay. Column 2. Where's column 2? Okay, this column 2. Why is it having -2? Then we come to our model to see. Is it supposed to have -2? No, it's not supposed to have. It's supposed to be 0, 0 on both axes. So that means there is probably, when we are doing our modeling or something, there is an error. Modeling in terms of AutoCAD work, I will do my check. Yeah. Here is -112.5 mm. Here is -117.5 mm. So which shows that this grid line is not sitting at the center of this column. So we can always edit it. So I'll assume that everything has the same condition as what we have here. So it's always important. So let's come back to the table property. So what we're going to do now is we equate everything here to be 0. Then we equate everything here to be 0. So with this now, any load that is coming on this column now will be at the center, will be at the centroid of the columns without any eccentricity. Do you understand what I mean by eccentricity?
Yes, sir.
That's a deviation. And with that deviation, it can induce moment. So with that, we are done. We are done with our column check. So we can start drawing our beams. Yes, our beam. Now, one good thing about this thing that we have done now is we can see an outline of our beam. So we can just draw on. That was what we are going to
Yes,
do.
yes.
We are going to draw on the outline we have here.
Yeah, before.
So I'll pick my column, pardon, our beam. Now the sizing of our beam, rather, we are taking it as 230 by 450. I think I've explained the reason why most people goes with 230 by 450 to you in our previous
Yes, sir.
classes. The 230, the
Yes,
width
sir.
is because most of our block wall is 225 to 30 thereabouts. Then the depth is within the range of provision that we have in BS code. You know, there is a table that talks about deflection. There is a
Yes.
length to depth ratio. So the best size that works with that is 450. You get to some country, they don't go with 450, they say 500. It's fine, it's not a big deal. But Nigeria is being economical, which is not a big deal. It's fine with the provision of the code. So we can say 450, 230. So what do we do now? We start drawing our beams.
Beams.
Then we give preference to primary beams before we draw secondary beam. Do you understand? Where you have
Yes, sir.
primary beam, secondary beam system, you have to draw your primary beam first before you draw your secondary beam. So that without basis known now, we cannot draw this beam yet. Are you with me? The beam on grid line A1 prime, A prime B. We cannot draw it first because the beam is resting on another beam
Yes, on two cantilevers.
on two cantilevers. So we cannot draw that first. So we check of option on 1. The way I'm doing it is I want to draw the horizontal beams first before I draw the vertical. So likewise, the beam on grid line 1 prime, D F prime, we cannot draw it because it's on two other beams.
1 prime.
D F
Okay,
prime.
okay, 1 prime. 1 prime. G F prime. Okay, okay, sir.
We cannot draw it too. So, but we have another horizontal beam that is on grid line 1A prime up to D. Yes, 1A prime up to D. That one you can draw it because from A prime to A is a cantilever. From A to B is a span that is in between two columns that we've already drawn. Then from B to D is another span and is a primary beam to the beam resting on it. So we can easily draw it. So that will be the first beam we'll
Yeah.
be drawing. Do you get that?
Yes, sir.
Okay. So the next grid line we are moving to is grid line 2 now. There's another beam on that grid line 2, and this beam starts from grid line C and it ends on grid line F prime. We cannot draw it because on grid line 2C, on point 2C, it is starting, is sorry, the beam is resting on another beam that we have not even drawn. So we cannot draw that beam yet. Then we'll move on to grid line 3. There is a,
3.
mind you,
Think we can.
if I throw the model up, there is always traces of the axis with what color is this? Like yellow color that you can use to reference the grid line. Do you understand what I'm saying? You know, this big circle grid line has gone off now. By the time I shift this thing up,
Okay.
so you can always see the small the yellow that is still going to tell you, okay,
Yellow.
what's the name of the grid line. So that will be our
Okay. Yeah,
reference. So the beam on the next beam, the
3.
next horizontal beam that we want to use on grid line 3 abi. Then we have
Yes.
one that starts on A prime and ends on where?
4 prime prime. No. C.
It ends on C. It ends on C. Can we draw it?
Yes, we can draw it.
We can draw it.
We have one.
Yes, because
We have one
here
river.
is actually a primary beam. On grid line 3A prime is a primary beam, so we have to draw it first. Then on grid line 3A, there is a column there that is supporting it. Then on grid line 3B is acting as a primary beam to another beam there. So we have to draw it first. Then on the head is we have column there that is supporting it. So we can easily draw that beam. So we draw. See, note, it's always good that when you are drawing your beam, you click, you select points. Like, let me come again. You see some people, if they want to draw this beam now, they will start here, then run it over here. The software will automatically break it since it's running over a column. Do you understand? But I don't
Yes, sir.
advise people to draw over like that. I always prefer to stop on each column. Stop on each column. It's very, very, very important. You will see the importance later as we go on.
Okay, sir.
So I click. So now, you know, I've cancelled the option of beam, but I want to continue drawing. So how do I do that? I click on already existing beam that I know it has the same property as the beam, as the new beam that I want to draw. So I'll click on it, then right click as we have done for the axis, then click on properties. With that property that we have clicked, you can draw another beam that is going to have the same property as that. But note, you have to be careful when using this option, because there are some times that your beam has end condition. What do I mean by end condition? You see this insertion method, there is one symbol there like a blue symbol. That symbol has, if you put your cursor on it, you see what it reads. It reads what? It reads what?
Hello, sir.
Hello? I'm referring to something here.
Okay, I can hear
My
you now.
cursor is currently on something. What does it read?
Your cursor is on blue
What
line,
does it
like
read?
insert beam method.
Beam end condition.
Okay, oh yeah, beam end condition.
Yes. So you have to be careful when you are using the option of you want to use the property of an existing beam to draw another beam. There are sometimes that the beam that you are referencing might have had end condition. What I mean by end condition is probably one end has been fixed or has been pinned, or the two ends can be fixed, or it might have any end condition. So just be careful. That's what I'm talking about there.
Okay, sir.
Now I will draw the beam. I'm drawn the beam. So what next? We move to grid line 5. Can we draw grid line 5? Yes, we can. It's a primary beam all the way. Then we move to grid line C prime. There is a beam there. Can we draw it? No, because at the point C prime C 6 prime C, the beam is actually a secondary beam there, and we have not drawn the primary beam, so we cannot draw that yet. Then we'll keep on moving. We move to grid line 7. Can we draw grid line 7? Yes, we can. It's primary beam all the way. Then we move to grid line 8. Can we draw that? Yes, it's a simply supported beam. So we are done with horizontal beams that we can draw for now. So we move to vertical beams. Like this now, the first vertical beam I will be considering is the one on the grid line A prime. Can we draw it?
Yes, sir.
Yes, we can.
We have drawn the two primary beams.
Yes, we have done the two primary beams already. Then we move on. The beam on grid line A, can we draw it? We start from grid line 3 and ends on grid line 8. Can we draw it?
Yes, we can draw it. We can draw it.
Exactly. It's all the way a primary beam. In fact, it's transfer beam safe. Okay, we are done with that. Then we have this guide that we are planning to fix on this beam. We can draw it soon. You can see the importance of the grid line we've created now before we imported our drawing into ProtaStructure.
Yes, sir.
With the grid lines we've created, we can easily draw everything without, okay, let's create another axis, let's create another axis. Everything has been automatically created. Then we keep on moving. Next game, can we draw this guy? Yes, I think you can draw this guy. Okay, very good. So we can complete this beam now. Then we move to this side. Can we draw this? Yes, we can draw it. Then we move to the next one. That's this one. Can we draw it? Yes, we can draw it. Then which other one? Can we draw this?
We can draw.
Which other one can we draw now?
That's 6 prime. Oh, it should means one beam.
6 prime.
Yeah,
This one,
yes, I can see.
we can't draw it here
Yes, this one is
because
where the last primary beam.
exactly. So which other vertical? Don't forget we are going in a particular direction.
But
So on the vertical axis, which other beam can we draw for now?
the last one,
The last one.
the
That's on grid line what? E.
E.
Exactly. So we can draw it. That's a cantilever. We're done with that. So which other one can we draw now? We are done with all the vertical beams that we can draw for now. So let's resume back to the horizontal. Let's come back here. I think we can draw the 6 prime we are talking about now.
Yes, we can do the 6 prime now.
Yes, we have drawn all the primary beams. Then we move up. I think we can draw this too.
And draw
The
2
beam
now.
on grid line 2.
Yes, we can draw it.
Stop here. Then which other beam? We can draw
D
this.
prime.
D prime. Which other one? We can draw D. D.
We can draw D. D,
Exactly.
yes.
Which other one? We can draw. Which one
I
are we
draw
going to
one.
draw first between beam on grid line F prime and 1 prime? F prime, 1 prime, 2, 2.
We
Which
are
one are we going
drawing
to draw
1
first?
prime.
1 prime
1
first.
prime.
Because it's acting as primary beam to the beam on grid line F prime.
And
So we draw this. Okay. With that, I can say we are done with our beams, right?
yes, sir, we are
We are
done.
done. So it's always good to double check
To check.
what you have done. So we compare with what we have. Maybe it's I want to compare with what we have. Is there any difference? We have done everything that's here. It's the same. 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 So we have not missed any beam, right?
Yes, sir.
We did not miss any beam.
No.
All right. So the next thing is I always like to define my beam end conditions. My beam end conditions. Like this beam now, what's the end condition? Is a simply supported beam. Naturally, the way your software sees all beams is it sees it at a fixed end on both sides. So what you are going to do now is to make it a simply support. That's why when you see some, let me say, some design to to say this kind of beam, you see the top reinforcement being T20, then it might be 2 T20, then the bottom reinforcement will be 2 to 16. That's telling you that this this beam, the designer forgot to give it the right end condition. So what we are going to do, we are going to give our beam end condition because it's simply supported. The two ends has to be pinned, and we know how pin support react. So that means our main reinforcement is going to be at the bottom, because what we are going to have is a sagging moment. By the time we have a pin support on grid line A prime, and we have another support, a pin support on grid line B. So by the time you run your analysis, you expect to have a sagging moment on beam 19. So that's what we are going to do now. So how do we do that? You click on the beam, you right click, then you see option. You see where you have update beam end conditions. Then we have 4 options there. We have no hinge, both end hinged, hinge at left end, hinge at right end. So what I'm going to do, since it's sleeping supported, we are going to hinge it both ends here. So it's going to tell you, do you want to apply it to all the beams? No, because all the beams on this floor, all of them are not simply supported. So if you click on all the beams in the story, that's a very bad option, unless if you know all the beams are simply supported. Apply to all beams in the model? No. So we are only applying it to the selected beam. So after doing that, you will see like a red point on the two ends. So this is telling us that this beam has been pinned on both sides. Do you understand?
Yes, sir.
So I will do that to all the horizontal beam first, in that same order, horizontal first before the vertical, so as not to miss anything. Then this one now, can you tell me which side, if I click on this beam and I make the end condition both side end hinged, is it right?
Yes.
Are you with me?
Yes, I'm with Susan.
I asked a question.
You said, is it me on both sides?
I said
Hello, sir.
this beam, can you see my screen?
Yes.
This
Yes.
beam 36, I want to choose the end condition for it, but the end condition I chose
Okay.
was two ends hinged. So I'm asking you, that is that option correct?
Yes, it is correct. It is the two end are hinged.
It's wrong. It's wrong. You can only hinge
Why,
two
sir?
ends if it is simply supported, like this beam 19 now. You know what hinge means? Let me quickly put you through something.
But
Now
hinge
I can hear you.
pin support now.
Huh?
I said hinge is pin support.
Yes, it's the same thing.
It's the same thing.
Yes.
Eh,
Now this is the beam I'm talking about.
yes.
I'm coming.
Yes. The line A, yeah,
This
between line
beam,
D and E.
let me just take this as reference. You see, this is the hinge we are talking about. What hinge is doing is going to make the moment at that point to be 0. Are you following me?
Okay, sir.
Are you there?
Yes, sir.
Please, I want to, yeah, just give me a few time. We soon end the class. Just probably in 10 minutes
I'm,
time, I will end the class.
I'm with you. I'm with you, sir.
Okay. Yeah, this beam is simply supported. Now,
Yes.
my question now is, well, it's not even a question, I'm explaining. At this end is pinned. What pin means is, or hinge means is, it's going to take the moment to 0. Do you understand?
Yes, sir.
Here also,
Yes.
we want to hinge it. It's going to take the moment to 0. Now, I'm now referring to this beam here, this beam. If I take the two ends to be 0, pardon, if I take the two ends to be hinged, which means the moment here on grid line D and the moment on grid line E is going to be 0, which is wrong analytically. That's not how the beam will behave. There is a cantilever at the end, which is going to create a top moment. So you are telling the software to analyze this beam at this span DE separately, and then analyze the cantilever beam also separately. So it's not going to take this beam as a continuous beam. That's just the implication.
Mm,
And
and that's
with
okay.
that, you might have more reinforcement for this beam
To the
than
cantilever.
expected.
For the cantilever.
Like this is what we ought to have. Coming. I want to sketch something. Okay. I want to sketch how the bending moment diagram is expected to be. Now, this is what we are expected to have, something similar to this.
Okay.
So we are supposed to have this cantilever to create a top moment here. But what we are doing, if we are making this end E to be hinged, that means you are taking this moment, the moment of your
To be
span
0.
here to be 0 here. Do you understand?
Yes, I understand
Then
you, sir.
another moment will be created here. So thank you for that. So in a nutshell, the end condition we are going to pick here is going to be to the left end. So we are only creating hinge or pin at this grid line D alone. This side will be free. So I'll continue. On here is going to be on the right hand side. I believe you understand that.
Yes.
Okay. Here, Enko, are we going to put any hinge support here?
Which beam?
This beam here. I'm on this beam now, the beam on grid line 1. I've reached this
Line
point.
one. Okay.
So I'm coming
No,
to why?
it is a continuous beam.
It's a continuous beam and it is cantilever here.
Cantilever.
You understand?
Yes.
So now this at the left hand, you make it pinned. You have pinned it. At the end is free. Here too, on the right side, you make it pinned because on the left side it is free. Then I am moving on. Here on the left side is going to be pinned, while at the other span, the right side will be pinned. So I'll be using the word pin and hinge interchangeably because they denote the same thing analytically.
Okay, no problem, sir.
So it's the same thing. Um, this just on the left side, then this just on the right side, and this, since it is simply supported, I'll take it both sides. So I'm done with all the horizontal beams. So it remains the vertical beams. This one on the okay. The left is down while the right is up. Just keep it just keep that at the back of your mind. The left is down while the right
Okay,
is up.
the right is up. Okay, sir.
So here now, the left, you have to
The
hinge
left
at the
hinge.
bottom, and at the top is going to be free. Which other beam along this axis? Okay, this one. This span, we have to hinge it at the top, so it's going to be right.
Okay, sir.
You can see it has created the hinge symbol, and this side is free. Then here we create the hinge down that has been created. And which other beam? This beam. Why is it not open? Okay. He's down. Sorry, down is left. Down is left. You can always change it. Assuming like I've done now, I made a mistake. I click on left instead of I click on
Right.
right instead of left. You can always change it. It will change. See, it has changed the symbol to up, which is wrong actually. So you can make it right. So it's actually left, not right. So it has switched down. So right as up and come down, left. Okay. This is simply supported, hinge on both sides. Here also, Here is not simply supported actually. What we'll do is left is down, right? So we
Yeah,
do it
left
left.
down.
This will be simply supported. So both ends will be hinged. Here, this being hinged down, left down. Okay. I think with this, we are done with all our beams. We have given them the right end conditions. Our beams have, they all have end conditions now. So the next thing we are going to do is we are going to draw our slab, and that would be my stopping point today. So how do we draw slab? You create your slab, you click on slab label here. This is the slab. Then you define your height. That's the thickness of your slab. 150 mm. Take it as 150 mm. Then the cover 25. If you like, you can take it to 30, but I would prefer to leave it as 25. Then the load combination, automatically the self weight of the slab has been calculated. For a 150 mm thick slab, the self weight is 3.6. Then here the imposed load, if you right click on it, it's going to give you options. If you right click on imposed load, it's going to give you options. Okay, imposed load for a general domestic use, imposed load for residential communal areas. All these loads are in accordance with the load we defined in the code the other time. That's BS 6399. So we put, since our project is a residential building, we just pick general domestic. Domestic use is enough. Then this dead load, it comprises of the finishing, the partition load, then the service load, probably your MEP. You know, they might want to hang something to your slab. You have to consider everything. So roughly everything depends. Some people might take it as 3, some people might reduce it to 2.5 depending. But for the sake of this project, we take it as 2.5, or we can take it to 3. 2.5 is small. Partition load is around 1.65. 1.65 plus serviceability of 1.0 kilonewton per meter square plus partition load. That's around 3 or so. Let's take it as 3.5. Fine. So with that, I draw my slabs. The insertion method we are using is beam, enclosed beam or something. Okay, beam region. So if you observe, once I click on the void, you are going to have like a thick line that goes around all the beams surrounding the void that I've clicked on. So that's the beam region option. So as I click on it, it's going to create slab straight up. And this. But here we have staircase here. Then don't forget we have a cantilever slab here. We have, I think, another cantilever slab here. Then we have one other minor slab in here. I think that's all as per the slab. So we go back to our AutoCAD to check. Okay, these are GA. So we have a slab here, and I believe we have created a grid line there. We have another slab here. We have another small slab here. We have another small slab here. Okay, so that's the next thing we want to do now. So we click on the existing slab, then you right click, you go to option, then you go to insertion, you click on insertion. What we are going to do now is we are going to pick axis. So once we are done with the axis, the slab will be created automatically. The axis surrounding the slab we want to create. So let's take for instance now, we want to create this slab here now. Is at the left side of grid line A. So where is it? This grid line A. We have created grid line around it. That's grid line A prime prime prime, 4 prime, A prime, about 7 prime rather. So I'll click on all those grid lines to create the slab. So I will start with 4 prime, 4 prime, clicked, A, clicked, 7 prime, clicked, then A prime prime prime, clicked. Then we click on the first axis we started with. That's 4 prime. Click on it. Should have created by now. Yeah, that's created. Do you get that method?
Yes, sir.
Okay. Then we delete that off because we are done with it. We create another one. We want to draw this slab beside the staircase. We already have the grid line around it. That's 4 prime prime. Then we have grid line E. Then we have grid line 5. Then we have grid line, which other grid line? D prime. So click on all of them. D prime, 4 prime, grid line E, grid line 5, then grid line D prime. Then we have our slab. That's how to do, that's how to create slab that are not within slab. I mean, that are not within beam. So we are not done. It remain like 2 other one. Start with 5 prime. 5 prime, F prime, 8 prime, and it moves on to E prime prime, and it moves on to 7, moves up to E, then comes back to 5 prime. You can see our slab has been created. Then the last slab, and that will be where I will stop for today. I'll delete the previous one I've drawn. Start with D prime, D prime prime rather, 8 prime prime, B, then we have the line 7, then we hand it up with line D prime prime. Created, just as we have it in the GA we created with AutoCAD. So we close it. Okay, so we are done with creation of slab, beams, and columns. So we can always check the 3D of what we have done. You click on view, the view option, you click on it, then you right click, then you see 3D view. So this is what we have worked on so far. And I think it's coming close to what we have in the architectural drawing. So in our next class, we are going to talk about how we are going to create story, then how we are going to draw our roof beam, then do analysis. I believe by the time we start next class, it's going to be faster because we won't be talking about the elementary things that we have talked about today. So as per your project, I wanted to send it yesterday, but while I was working, I could not finish soon. Maybe after this class, I will send it to you.
Okay, are
So
you
you can
sending it
start.
today?
Huh?
I said, are you sending it today?
Yeah, yes. I'm feeling it today. I'm so sorry.
Okay.
Okay, so our next class is going to be on Tuesday.
Tuesday.
Yes, 1 p.m.
Yes.
If there is going to
1
be,
p.m. Okay.
yes, 1 p.m. Is it not convenient for you?
Huh?
It's not convenient for you, right? I mean the time.
Hello, I can hear you.
Hello, I mean the time
Yes.
is not convenient for you, right?
That one. I'll make it. I'll be available. I'll make myself available for that. I'll plan towards it.
Okay, if there's going to be perhaps any changes, I'll communicate across through the Discord platform.
Okay, sir.
All right. So have a nice
Okay,
weekend.
thank
If you have
thank
any
you very
question, you can always throw it to the platform. All right. Have a nice day.
much. Okay. Okay.
You wanted
All
to
right,
say
sir.
something?
Yes, about this my software,
Okay.
the ProtaStructure that I've been trying to activate it. It's just in activation field, invalid license key.
What have you tried the cracker I sent you?
Yes, I tried.
Okay, it's not working.
I tried it.
Okay, that's not a big deal. What you do now is the link I sent, you can download a new version, but although that one is not 2019, it's 2018. So you have to uninstall the one you have installed, then you make sure you delete the program file from your
Yes,
laptop.
the 2018 abi.
Yes, the 2018. To install it,
Okay.
you have to delete the program file of the existing one, go to your PC, go to program file, go to ProtaStructure, or you go to document. I think now it saves in document. Delete anything that is related to ProtaStructure on your laptop, then reinstall the 2018 all over. I think that will work.
Okay, sir.
All right.
Thank
So
you.
keep me informed if you have any issues.
Okay, sir.
All right. Yeah. As for a project, I'll send it to you.
Okay, sir.
All
Thank you
right.
very
Yeah.
much.
Have a nice day.